This video is going to explain the automatic testing equipment of the Smart Pulse controller. This software is used to test all the parameters in the filter system and will generate the test report for every parameters. This is the setup of the automatic testing equipment. All the ATE boards is connected with the Smart Pulse controllers. All the inputs and the outputs are provided from the ATE hardware. This is the master controller of the filter system. Our ATE software is connected with this master controller system. We will see how the ATE software is going to test all the parameters in the filter system. This is the ATE software. First we have to connect the ATE software with our master. After opening the ATE software, the first thing we have to do is we have to configure the filter settings. The configuration settings is already downloaded from the SPC controller using the Smart Tool application. Now the file is uploaded in the ATE software. We can see all the settings which is present in the SPC controller is uploaded in the ATE software. All the alarm settings and the field settings, everything is uploaded to the ATE master. The factory settings also uploaded in the ATE controller. We can see the damper and isolation valve enable disable conditions. And also we can see the individual hopper settings in the ATE controller. We can verify all the settings in the ATE compared with the master controller. And this is the special tab in which we can enter all the tag numbers. Each panel is represented by the tag numbers. We can enter this tag number in this page and we can generate the test report for each panel. After verify all the settings, click the generate button to save the settings. Here also we can enter the project name and the FLS order number in the ATE software. After check all the things, first we are going to test the differential pressure and system pressure in the filter system. Go to that page and click start test. DP and SP are the analog inputs. So the ATE software will check these two parameters for the 4 to 20 milliamps, and also it will check the wire break and shortcut alarms. In our controller we can see that the test is generated by the ATE one by one for the system pressure and the differential pressure. Like the system pressure and DP, we can also check the manifold pressure and manifold BBD. Now the test has been started from the ATE. Manifold pressure and manifold BBD also the analog inputs. In our controller, in the manifold controller, we can see that the manifold wire break, shortcut alarms, and also the values for 4 to 20 milliamps are checked. Likewise, the ATE will check the manifold BBD also. Likewise, the ATE software will check all the temperature inputs present in the SPC control system. Next, the ATE is going to check the feedbacks and status in the SPC control system. Now the test has been started from the ATE. We can see that the ATE is checking the feedback of the outlet dampers, isolation valve, inlet damper, and also the level switch. First, the ATE will check the outlet damper status. In the controller, we can see the status check in the status report. We can see that the outlet damper feedbacks are changed and verified by the ATE. Likewise, the ATE will check the status of the isolation valve. After completing the checking of the isolation valve, the ATE will check the status of the inlet dampers in the hopper area. In our controller, in status report, we can see that inlet damper status are changed by ATE and also verified by the ATE. Likewise, the controller will check the status of the level switch also. Next, the controller is going to check all the alarms in the SPC system. Now the test has been started from the ATE. It will check the wire break and shortcut alarms for the dampers. Now we can see that the wire break and shortcut alarms are generated and verified by the ATE. Likewise, it can check the alarms for isolation valve, inlet dampers, and for manifold pressure. All the alarms can be generated by the ATE and verified. Next, the ATE is going to test the online cleaning function of the SPC controller system. For that, first we have to load the sequence in the ATE, in which sequence the ATE is going to purge the purge valves in the SPC controller system. After choosing the sequence file, click the Start Test button to start the test. Now the ATE will send the purging command to the master to check all the status of the valves. ATE will check all the valves in the SPC controller system and will generate the report for each and every valve. In our controller, we can see that the online cleaning is started from the ATE. It will check the valves one by one. We can see the status of the valves in the LCD display. Next, the ATE is going to test the valve alarms. To test valve alarms, first we have to load the sequence in the ATE. After loading the sequence, the testing will be started. The ATE will check the wire break and shortcut alarms for every valves in the SPC system. It will check one by one. It will check all the valves in the SPC system and will generate the test report for every valves. Next, we are going to see the special alarms in the SPC controller system. Now the test has been started from the ATE. We can see that differential pressure, system pressure and temperature alarms are checked one by one. High, low alarms have been checked in this part. After check all these conditions, next the ATE will check the local alarm of the sleeves. After check the local alarm, it also check the communication error alarm also. After all the test has been completed, the ATE will generate the test report for each and every parameter in the SPC controller system. We can see the test report now. In that we can see that in which condition the parameters are checked and the expected output and the actual output and the test result all are present in the test report. The test report will be generated with the project name and also with the FLS order number. Likewise, the ATE will check all the parameters in the SPC controller system and will generate the test report for each and every component of the SPC controller system.